Now next, let us try to understand the concept of broadcast domain and collision domain with the help of an example. So you can see that in this topology, the host machine G, E, D and F are connected to the same physical wire. In fact, the L3 router is also connected to the same physical wire through an interface IFR. Now let us try to find the broadcast domain and collision domain for a host machine G. Now let us apply the definitions that we have learned regarding how to find the broadcast domain and collision domain. So let us try to find the broadcast domain of host machine G. Now suppose the machine G issue a R broadcast message and plays the message on the physical wire. So that particular R broadcast message will going to be received by L3 router, by machine D, by machine F as well as by machine E. Right? Because they all are present in the same subnet. So by definition, the broadcast domain of machine G is actually the entire physical wire. So you can see that finding the broadcast domain of a given host machine is easy. The set of all the machines which receives the R broadcast request message generated by the host machine G comes under the broadcast domain of host machine G. Right? Now let us try to find the collision domain. Now you can see in this topology, all the machines, that is all the host machine and the L3 router are connected to the same physical wire. It means that, for example, if machine G places a frame on the wire, then the electrical signals placed by the machine G on this physical wire will going to be detected by all other machines present to the same physical wire. It means that when machine G transmits a frame on the physical wire, no other machine connected to the same physical wire is allowed to transmit a frame on this physical wire. So it means that the collision domain of host machine G is the entire physical wire. So in this topology, for a host machine G, there is one collision domain and there is one broadcast domain. And in fact, for this topology, the collision domain is same as the broadcast domain. So apply the analogy that if machine G places the frame on this physical wire, assume that the physical wire carries a current and you will die if you touch this wire. So it means that when machine G transmits a frame on the physical wire, the host machine EFD along with the layer 3 router has to wait to transmit their own frames. Right? Now let us discuss the second example. Now in this example, we have placed an L2 switch in the topology. Now again, let us try to find the broadcast domain of host machine G. Now if host machine G issue an R broadcast message, then that R broadcast message will going to be received by all other host machines along with the L3 router. It means that the broadcast domain of the host machine G is the entire topology. So this is the broadcast domain of machine G. So for broadcast domain, simply apply the definition and you will find the broadcast domain of a given host machine. Now let us come to the collision domain. Now in this case, you can see that the host machine G is connected to this physical wire, and there is no other host machine which is directly connected to this physical wire. So it means that the collision domain of machine G is actually restricted to this physical wire only. The machine G will suffer collision when L2 switch places its frame on this wire and machine G places its frame on the same physical wire at the same time. So therefore, the collision domain for the host machine G is confined to this physical wire only. So the same applies to all other host machines. So the collision domain for the host machine E will be this one, and the collision domain for the host machine F will be this one, and the collision domain for the host machine D will be this one, and the collision domain for the L3 router will be this one. So you can see that by placing an L2 switch in the topology, you have actually reduced the collision domain from one big collision domain in the previous example to 5 smaller collision domains. So you can see in this topology there are 5 collision domains. whereas there continues to be one big broadcast domain. So the conclusion that you can draw from here is that L2 switch is a device which splits the bigger collision domain into smaller collision domains. So in the second diagram, host machine G, E, F, D as well as the L3 router can transmit at the same time, because they suffer no collision with any other machines in the topology. So the network deployment in the second diagram is actually more efficient than the first one. So one big conclusion that we draw from here is that L2 switches split the bigger collision domain into smaller collision domains.